Hi folks, my name is Damien Orangi and I'm a Senior Principal Engineering Technologist here with Dell Technologies. And in this series, we're going to build out a secure and robust MLOps environment with PowerScale and ClearML. So as we're seeing, the world of enterprise storage is certainly transforming as AI and machine learning are reshaping how organizations operate. And the role of the storage administrator is certainly evolving dramatically as well. We're no longer managing capacity, we're becoming the guardians of an organization's most valuable assets, right? And today's storage administrators face a unique challenge. On one side, we have traditional responsibilities, ensuring data availability, protection, performance. On the other hand, being asked to support complex ML workflows, take a look at managing model versioning and ensure compliance for AI systems as well. So this new intersection of storage and security and AI operations is certainly creating some new challenges. We've got to balance compliance requirements with the need for rapid experimentation with these teams. We've got to look to maintain a security posture while delivering high throughput and performance. And we've got to look at integrating MLOps tools such as ClearML in this example, while preserving security boundaries and controlling data sprawl as data sets move between training environments. So what does this really mean in practice, and how do we look to transform these requirements into a technical reality? So whether you're a storage admin supporting AI initiatives or an ML ops engineer trying to understand infrastructure security, or like me, who's someone who's trying to bridge all of these worlds, this series aims to provide some practical insights you may need and how you can leverage PowerScale to build a secure and robust MLOps environment, in this case with ClearML. Okay, so let's take a look at what we're aiming to build here over the next couple of videos. So over the next several episodes, we'll aim to build a comprehensive and secure MLOps pipeline powered by PowerScale and ClearML. So in this first video, we'll start with the basics in terms of folder structure for our environment, laying down our networking and DNS so we can configure PowerScale or OneFS features such as Smart Connect and access zones. And through subsequent videos and technical blogs, we'll work our way through the environment as you can see here on the screen by deploying a configuring rancher that will host our ClearML server environment and worker nodes, etc. We set up our CSI and persistent volume claims, along with some best practices on how we can leverage PowerScale for version control, data integrity, and compliance. At the risk of repeating myself too much, this specific video, we're just going to cover the networking, the access zones, and the basic MLOps setup. This will give us the foundation for a secure and isolated MLOps environment. So let's begin with the folder structure. As we know, a well-organized directory layout is the backbone of an efficient MLOps environment. Following PowerScale best practices and ClearML best practices, we're going to set up paths for artifacts, some datasets, some logs, models, and Kubernetes storage. So this structure will support scalability and will simplify down the road integration with tools like Kubernetes and ClearML. Okay, so we'll have our artifacts folder for training outputs, metrics, and results. Have a datasets folder, which will also have the raw datasets, the process data, and test datasets. We'll set up a logs folder for training logs, system logs, application logs. We will have our models folder where we'll have our train models, our checkpoint data, and our production models. And then we'll have a folder as well for our persistent volume claims, our rancher cluster storage, and our persistent volumes as well. Okay, first things first, and this is laid out as well in the technical blog, which I'll leave a link for down below. We're going to lay out the dedicated networking and DNS as follows. So we want to create an isolated environment for ClearML MLOps engineers, so to speak, for security, for governance, and as importantly, for performance reasons. So we're going to leverage PowerScale features to achieve this by way of access zones and Smart Connect, which will allow us to dedicate bandwidth and manage cluster utilization evenly. So that's the preamble over. Let's jump over now. This is going to be a relatively short video this time around, where we'll just step through what we've talked about here. Okay, so here we are in our lab. We've just logged into our OneFS dashboard here for our PowerScale cluster. So first thing that we're going to do is actually just set up the folders. So if we go into our File System Explorer, I have all this built out already, but we'll just step through it again quickly. So here's our, we'll get to the access zones in a moment, but because I have it built out, we have to go to the MLab access zone view. But we can see here very simply, I've defined my folders for the MLOps environment. So we have our artifacts, our datasets, our logs, our models, and our RKE2 MLOps. This will be for the persistent volume claims. So that's what you're going to do first, is quite simply go in here and create your directories and create each folder appropriately. So first things first, what we want to do before we can actually create our access zone is we're going to have to define our networking. So let's go down here to our network configuration. Again, I have this built out, and this is covered step by step, is actually covered in the accompanying technical blog. So because we're using access zones, we're going to have to create a dedicated group net for this. So this is a separate network, which is great. So I have this VLANed out on the switch. So I've chosen a 192.168.30/24 network for this. So you can see this is actually separate to our standard kind of system access zone, which is sitting on a 10.0 network. So we have this isolated here, which is sitting on a different physical NIC and is actually VLANed out. So first things first, we'll be defining firewall rules later on, but we just want to get the basic implementation up and running first, right? So what we would typically do here is we would go to add group net, and that's where you would define your interface. So I will just step through it here. So we'll just go view edit here so we can understand what I actually built out here on the lab. So no surprise here, I've called the subnet MLOps. Give it a brief description. I've actually given it my VLAN number just so I don't forget. And I have my default gateway here configured. So the most important thing here really is the Smart Connect service IP. So I've chosen 30.30 as the Smart Connect service IP address, and what I'll show you in a few minutes is essentially our DNS delegation is going to point towards this IP address. So we have it defined there. Just put it in twice because we're just using a single IP address in this regard. So we'll cancel that out. I have my DNS server here configured as well. This is an internal DNS server. So let's go into the actual pool here, where this is actually the IP addresses that will be serving the traffic, right? So I've called it ML pool, and here I've chosen .31 to 35 because I have 4 nodes in the PowerScale cluster. So that's an IP address each per node here that we can see. And you can see that that's actually assigned to ext2 is the interface, and that is what the access zone is going to be configured to as well. So if we scroll down here to the access zone, I'm going to give it a zone name here of mllab.lab.local and leave it as round robin as the aggregation mode. Okay, so once you have your networking actually configured and set up, again, it's outlined in the accompanying technical blog. Once we've got our folder structure and we've got our networking defined, then we can go ahead and actually set up our access zone. So again, I have the access zone already set up here, which I've called ML-lab. Okay, so we'll just go in and quickly look at it. It's quite straightforward. The base directory here, you can see, goes into data cluster 01 ML lab. So that's going to be our entry point. So when we do any mounts to mllab.lab.local, it's going to go into this ML lab base directory, but we'll see that here shortly. What I typically do is once the access zone is created, I'll go back to network configuration here, and in the actual pool, that's where you specify the access zone here. So if we go down here, you can see that we have MLab associated. So this IP address scheme is associated with this entry point here, MLab. So next we want to go over here to our protocols and actually just do an NFS export here, just by way of a test. So let's just load this here. And let's change our access zone to MLab. And you can see here I've already actually set up an export to the datasets folder. So I've left everything open and unsecured at the moment. We will lock it down in subsequent videos, but we just want to make sure that everything works as expected with our access zone for the moment. So that's everything really from a kind of a simplistic high-level overview that we have to set up just for our base configuration for the PowerScale array. Okay, so let's just jump over now to the DNS server, because we want to follow best practices here and actually set up a proper delegation here to the Smart Connect. So you can see here I've set up an A record, a host record here for the Smart Connect, and I've just defined it as cluster01-SSIP, and that's pointing to that 192.168.30.30 IP address that I just showed you earlier on in the networking configuration section in the 1FS GUI. Okay, so that's the first thing we're going to do. So if we look this up, we're going to get this IP address returned, and essentially that is the service IP address of Smart Connect. And what we're going to do is we're going to set up a delegation for that, right? So if we look up mllab.lab.local, we want it to essentially point out here, and we want that to resolve to a pool IP address. So I've gone ahead and done that already. And you can see here, if we just edit this here, we can see that that Smart Connect IP address here is active and responding. So ml-lab.lab.local is going to forward on to cluster01-SSIP, or in reality it's going to hit this IP address here. Okay, so what am I really talking about here? If we open up a PuTTY session here to a host that I have, let's just clear this out. And we'll perform an NS lookup for that lab, right, for that DNS entry. So that's what we're looking for there, right? So if we do an NS lookup for mllab.lab.local, we can see actually that we're getting a node IP address responded, not the 30.30. That's our delegation, that's our upstream DNS server. What we actually want is, because that doesn't serve traffic, what we want is the actual 31, or any IP address from that node pool actually returns. So .31, .32, 33, 34, right? That's what we want. That we want that round robin fashion. So we know we're good now, right? So we know that we can actually reach this endpoint of mllab.lab.local, and we're going to get an actual proper node IP address returned from that. So that basically means that Smart Connect is working and the actual access zone is working as expected. So let's just verify that quickly by just checking if our mount is working okay. So I believe I have a mount done already. As we can see here, I have data sets mounted, and you can see that that is mounted here into this access zone. So that's it for this demo. That's kind of the basic networking and DNS actually configured and set up. So in the next video, what we'll actually step through now is configuring Rancher and actually setting up the Kubernetes side of the environment. Thank you for your time, and we shall see you in the next video.